Hello, it's November, well, it's not November 9th, but these notes should be on November 9th. So, indirect proof and inequalities in two triangles. Not likely that that's going to show up on a test. It's pretty tricky to test in person, much less online, but we'll still go over it. So, starting off the warm-up, you hopefully have done that already. Try to do your warm-ups before you start the videos. So, the triangle has two sides of 4 centimeters. What length is possible for the third side? So if you remember, the way we do that is we take and we subtract two sides and we add the two sides. Very simple. That's going to give us the least and the greatest boundary. So if we subtract the two sides, we get 0, and if we add the two sides, we get 8, which means that our side has to be between 0 and 8. Cannot be equal to 0 or 8. Has to be between 0 or 8. And 0 wouldn't make sense anyway. This is a side length of 0. So, what length is possible? 0 is not possible. 7 looks good. But on a multiple choice test, when you come up to the answer you think is good, it's still a good idea to check those other two answers because they might give you an idea, or you might say, well, that looks good too, and then you'll think about it some more. So I'm pretty sure B is the answer. C is, now it can't be the boundary. It has to be less than the boundary. And D, that's way too big. So the answer is B. Okay, and I could have crossed those off as I was going. No, those don't work. Now it's important, this was the other day I said, be careful. This on a test or a worksheet or whatever, that's the equivalent of a teacher yelling, be careful. All caps, bold, underlined, saying, watch out, read. Be careful. Don't assume that. So what length is not possible for the third side? So 2 is in between there. That's fine. 4 is in between there. That's fine. 6 is in between there. That's fine. And again, 8 is a boundary. That is not possible. If the third side was 8, you would have 2 4s and an 8. You couldn't make a triangle out of that because the 2 4s, if you try to lift them up to put some angles, then they won't touch anymore. That doesn't work. Okay, so let's see what we have here. So, an indirect proof. Identify the statement you want to prove is true. Okay, so use indirect proof to prove the triangle cannot have more than one right angle. So, identify the statement you want to prove is true. So you want to prove the triangle cannot have more than one right angle. That's what you're trying to prove. Okay, so there's step 1. That was pretty easy. Step 2, begin by assuming that the statement is false. So take that, and if it was false, it would be a triangle, let's just say has 2 right angles. That would be assuming the statement is false. If it cannot have more than one, then 2 would be a assumption that that's false. Opposite. I don't say it's opposite, but anyway. So, excuse me. Obtain statements that logically follow from your assumption. Okay. All right. So, triangle, so let's go measure of angle A plus the measure of angle B plus the measure of angle C equals 180 degrees. That's the triangle sum theorem. Okay. Now, if it has 2 right angles, we could say whichever ones we want. B equals 90. Measure of angle B equals 90. Measure of angle C equals 90. Okay. So that's just part of our assumption. That doesn't have a... So now if we do this, we'll have the measure of angle A plus 90 equals 180. So basically we just substituted those in there. So that's the substitution property of equality. This was our assumption, so that doesn't really have a thing there. So if we add those together and subtract from both sides, then we would get the measure of angle A equals 0. And that is a contradiction. That can't happen. We can't have an angle that measures 0. So a triangle can't have more than one right angle. We just showed why. Okay? Don't let that freak you out too much. It's not that important in this class. But it exists, so just thought you should know about it. Oops. Part of that was behind the thing there, I think. Why don't you guys tell me that? If you were in class, you would have been able to tell me. Alright, hinge theorem. The hinge theorem says that if two sides of a triangle are congruent to two sides of another triangle, and the included angle of one is larger than the included angle of the other. So let's just see. So I'm going to do a 1/2 inch and an inch. Okay. So those are my two sides that are the same. Well, not the same as each other, the same as the other one. So there's two congruent sides, and do that again over here. So 1/2 inch, and now I want to do a bigger angle, but I want to keep the side lengths the same. I guess I'm going to come over here. Okay, so that's the 1/2 inch side matching this 1/2 inch side, and there's the inch side matching that inch side. So two sides of a triangle. So I'm going to turn that into a triangle. And over here. Okay, so now if two sides of a triangle are congruent to two sides of another triangle, and the included angle of the, okay, so I do them backwards. So the included angle of the first triangle is larger than the included angle. So the included angle is the angle that's included between the two equal sides. Okay, so this needs to be our first triangle. And this needs to be our second triangle. Go backwards. So if the first included angle, is larger than the second included angle, then the third side of the first triangle is larger than the third side of the second triangle. So that kind of should make sense. So if you have a hinge, and then the greater that the angle is between those sides, the greater that side's going to be. That's how a door works. So when you open a door, the hinge opens the door, and the bigger the angle on the hinge, the bigger the opening is to the door. So if you want to get through the door, you open the door up, and you increase the size of that angle. And by increasing the size of the angle where the hinge is at, you increase the opening. You increase that side of the triangle. So that's why it's called the hinge theorem. Okay, I should not, usually we put 1 mark to show that they're congruent, so I should put 2 marks on this one to show that they're different. Okay? You can see that one either. Alright. Converse. So the converse means change the order. It means go backwards. So if two sides of a triangle are congruent to two sides of another triangle, and the third side of the first is longer than the third side of the second, then the included angle of the first, blah, 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 blah. Is that all you heard? Or did you even hear that? So now it's saying, same situation, two equal sides of one triangle, two equal sides of another triangle. If one triangle, the third side is bigger than the third side of the other one, then the angle across from it is bigger also. So that's all that says. Okay. In these two triangles, AC is congruent to DF. There's a lot of information here. Which is possible for the measure of angle C? All right, angle C. Okay, so BC and AC. BC goes with EF, and AC goes with DF. Why am I doing that? Because those are the two segments on the side of that angle. If I'm talking about angle C, then I'm talking about segment AC, and I'm talking about segment BC. And then similarly over here. So AC is congruent to DF, those match, and BCEF, BCEF, they match. Okay, so they're talking about angle C and angle F. So AB, this is a bit tricky. I'm just going to sketch a picture. Now I am not going to try to get the sizes of this right. I'm going to go by what I label. So I'm not even trying to measure it or anything like that. So A, B, C, and A goes with D, and B goes with E, and C goes with F, hopefully. AC is congruent to DF. BC is congruent to EF. Okay. Then it says AB is 11, and it says DE is 15, and it says F is 58 degrees. Okay, so this isn't drawn exactly properly, but it gives me enough information to figure out what's happening. So based on the converse of the hinge theorem, since these two sides are equal to these two sides, we have these angles here. Since this side is bigger, not drawn bigger, but the number is bigger, they told us, that means this angle should be bigger than this angle. Since this side is smaller, its angle should be smaller. If this side was bigger, its angle would be bigger. So that means angle C, the measure of angle C, has to be less than F. So it has to be less than 58. There's only one choice for that. 45 is less than 58. Okay? And the way you could look at that is AB is less than DE. So the measure of angle C needs to be less than 58. All right? So this looks like a similar question. So I'm just going to sketch out two triangles again. I really could have used my protractor, I guess, make that look a little bit better. Look how much nicer this one looks. Maybe. Okay, again, I'm not that concerned about it matching up perfectly. I'm just trying to get an idea of what's happening here. So GH goes with JK, and HI goes with KL. Okay, so GH, JK, HI, KL. Okay, GI is 9, H is 45, and K is 65. What is the possible length of JL? Okay, again, the pictures don't have to be to scale, they don't have to be perfect. So the point here is that these two are equal to these two, so that creates the hinge situation. And 45 is less than 65. So since 45 is less than 65, that means that 9 should be less than JL, which means JL has to be more than 9. So it's got to be 11. All right. And moving right along, so you and a friend are flying separate airplanes, same airport. You fly 200 due north. Okay. And then you change direction. Never eat soggy waffles. All right. And you fly 200 miles north. And then you change direction and fly 60 degrees west of north. So what that means is you go up to here, and then 60 degrees, oh no, it goes this way, north of west, 60 degrees north of west. 60 degrees north of west. It's kind of awkward. So if I put a 60-degree angle up here, something like this, that's a shorter distance, 90 miles. Alright, so this is 60 degrees right here, but this is 90. So that angle is 150. Okay? Your friend flies 200 miles due south, and then she changes direction, flies 15 degrees south of east. Okay. 15 degrees south of east for 90 miles. How long did I make 90 miles there? About almost half an inch. Alright, so 15 degrees, that's not very much. Okay, so that makes that 90 plus 15, that's 105. It's going to be 105 degrees. Okay, now each of you has flown 290 miles, but which plane is further from the airport? Okay. So let's look at this. So this is the distance, this person's distance back, and this is your distance back. So this is you, and this is your friend. Okay, so this side equals this side, that's the 90s, and this side equals this side, that's the 200s. But 105 is less than 150. This is you, this is your friend. So your friend went less than you. So my plane is farther. All right? And a little awkward. Don't stress out about it too much. Okay, these questions used to be a huge part of our tests. If you've done a couple of those, you maybe have seen some of them. So a little bit harder to do in an online format. So I'm still highlighting it because as we did, so you need to be able to graph lines and do certain things. So this is in point slope form. It's called point slope form because you should be able to see there's a point and a slope. And you can just graph it immediately. Some teachers make students switch that to y equals mx plus b. I know why some do it, just to have them practice. And there's some kids in class that need that practice. But really, you should just stick with what it is. So it's the opposite of that, so that's 3. And it's the opposite of that, so that's 1. So 3, 1. So you just come over here, 3, 1, and you plot that point. You don't have to do solving and distributing and all that stuff. Plus, the y-intercept looks like it's going to be pretty unpleasant there anyway, so you're going to have to approximate that, so that's no good. So just leave it. Use the point, and then now use the slope. So down 3 over 7. 1, 2, 3, 4, 5, 6, 7. And up 3 over 7. And over 7, I'll take it off the graph. Okay? When you graph, when you do this, try to get your point right in the middle, not in the middle of your point necessarily, on the lattice point. Remember lattice, when grid lines cross each other, those are called lattice points. So I'm trying to line this up, and I usually take the furthest apart from each other, so I'm trying to line it up with this one over here, not the one in the middle. So that looks decent. Looks like I might have missed up here just barely, but maybe. That's pretty close. Okay, now we have this. Now, hopefully you're starting to recognize those. That's a horizontal line at -2. Now, on these worksheets that we give you, these lines should cross each other perfectly. So if they don't cross each other perfectly at the lattice point, you made a mistake. Or we did, but probably you did. Okay? So you can write yourself a note of that right now. I don't normally write that, but they're going to cross at a lattice point. Same thing for the other line I graph on here. So if you go graph some line and it's not going through exactly, you probably made a mistake. You better figure out what you should do. All right. The last one is in standard form. And usually when something's in standard form, what I like to do is use the x and the y-intercept. So if x is 0, then we can divide both sides by -1, y equals -2. But if y equals 0, then x equals 2. So 2, 0 is right here, and 0, -2 is down here. And hopefully you all can see the triangle that we have right there. Now, on our test, sometimes we'll have multiple things on the graph, so you don't necessarily want to draw the line all the way across. Once you can see where it is, then, so you notice on that last line I didn't draw it all the way across there, even though this is the only question on this graph. All right. So, little coloring action here. So when you graph those lines, you're going to get a triangle, and then you're going to have some questions about those triangles. And so if you weren't careful, you could lose a lot of points on this question. So the first question says, use the vertical altitude to find the area of the triangle created. So an altitude is from a vertex perpendicular to the opposite side, or the opposite side extended. So that's 3. So the area of the triangle is 1/2 the base, which looks like 10 times, that's 3. So that's 5 times 3, that's 15 units squared. Okay. Find the lengths of each side and then find the perimeters. So, I guess I could have said that light blue was horizontal, like the horizon. Vertical, like jump, is up and down. That's point slope form, that's standard form. All right, find the length of each side, then find the perimeter. So this light blue side, 1, 2, 3, pretty much 10. So I don't really have a label on that, but 3 and 7 is 10. Now this one, we can use the Pythagorean theorem to find this side. So that's 3 and that's 3. So you're going to have 3 squared plus 3 squared equals c squared. So that's 2 9s. So you can factor out a 9 and get 9√2, since it's 9 times 9. And then we square root both. Did I already do that? No, this would be root 9 times 2, so that would be 3√2. Should have used a different color for that. That was purple. Okay. Now the last one is 3 by 7. So you're going to have 3 squared plus 7 squared, 9, 49, 58. 58 doesn't really reduce. Like 2 and 29, but that doesn't factor. So the perimeter is going to be 10 plus 3√2 plus root 58. Not 88, 58. Brain was focused on the 8. Okay. Units. Classify the triangle. The sides are all different. That's scalene. The angles of the triangle, well, that looks obtuse, actually. If it was right, it would come down here and hit 4 right there and make a perfect little isosceles triangle. So none of the angles are equal, but we have an obtuse one up there. So scalene and obtuse. Excuse me. All right, let's wrap this up. So we have a couple choices here. We did one like this the other day. We could add 48 to both sides. We could divide by 3. We could square root both sides, get the absolute value of x equals 4. We get x equals plus or minus 4. Now you also could have factored that, because you could have factored a 3 out and you got x squared minus 16. And that's the difference of 2 squares. That'd be x plus 4, x minus 4, which would also give us what we need, negative 4 and positive 4. That's what we have. Okay. Now we had one like this before. So I hope you guys have a good idea, you men and ladies have an idea of how to do this. So hopefully you can pause it and do this whole thing yourself. 32 divide by 2 . Then you're going to take the square root of both sides. You're going to get the absolute value of x minus 3 equals 4. So x minus 3 equals 4, or x minus 3 equals negative 4. So, so x equals 7 or negative 1. All right, so might be the quadratic formula. Let's think about getting that in the middle, and that is going to be the quadratic formula. So it's set equal to 0. It's in standard form, in order, x squared, x number. So it's the opposite of b, plus or minus square root of b squared minus 4ac all over 2a. So over here, we're going to have 1, and it's a negative times a negative. So that's going to be positive, so it's going to be 16. So we have 1 plus or minus root 17 over 4. So on Alex, I think they make us type those in separately. So you'd have to pick the 2 little boxes, and then there's a dot, 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 maybe a list or something. You click on that, it opens up a box, you start typing the box, then you got to hit the fraction one over there, like that, to make a fraction. And then you're going to have to enter these in separately. So like that, and then, except it's a 17 maybe. All right, I think it's about that time. Have a good day.